So here, last class we have started with the some what is the electro-optic effect and what are the electro-optic modulators are available. This we have started. Under the electro-optic modulator, there is one phase modulator, and apart from that, the intensity modulator is also there. Intensity modulator, that is also known as the amplitude modulator. So we know that amplitude modulator, normally if you want to see the graph of the amplitude modulator, it will be like that, right? If you analog amplitude modulator, if you see the, you can see the graph will be like that, carrying the message signal with the help of the carrier signal, like that, right? So here the intensity modulator, that is also in case of the optical signal also, the intensity modulator, that is also known as the amplitude modulator. That means the amplitude modulator, we are making indirectly we are making the amplitude modulator, which can change the intensity of the light when it passes through the modulator, right? So if you want to sometime in optical integrated circuit also, if you want to change the light intensity, so dimming the light and brightness of the light, so for those application we can use the intensity modulator. So suppose the intensity is like that, the higher intensity, after some time, so it will be like that only, so higher intensity and then low intensity. So using the amplitude modulator, we can get such kind of the signal at the output side. Normally in modulators we can use the crystal modulator, which where the electric index will change if we apply the electric field, and as the reflecting index will change, the orientation of the light and the intensity will be modified, so that we can get the higher intensity light as well as the lower intensity light. What are the things that are required to make an amplitude modulator or intensity modulator, right? Normally when this intensity modulator is mainly required, okay, so we can use the phase modulator for changing the phase of the signal for an optical communication application. Sometimes this the of modulation signal is not sufficient for the optical communication signal. So once we get the signal from the phase modulator, after that, and it should be the intensity of the modulator should be increased or decreased. So for that, intensity modulator is also required. So to make electro intensity modulator, you need your pocket cell. That I told that if the reflecting index is changed with respect to the with proportional to the electric field, that material is called that the phenomena inside this material. This concept is called the pocket cell. The device pocket effect, and the device is called as a pocket cell. Okay, that is called as a pocket cell. So normally in case of the intensity modulator, suppose from the phase modulator only you are getting the signal, that the signal you are getting, that is coming from the phase modulator. Okay, that is coming from the phase modulator. This signal is propagating through one polarizer, and again from the polarizer, again the light will pass through the pocket cell, and from the pocket cell again it will come into the polarizer, and again you will get the intensity. Normally what will happen, suppose there is a polarization light which is in different orientation, suppose 45-degree orientation polarization light is there, right? So this light will come into come through, this light will pass through the this polarizer one. Then the whatever it depends on the polarizer, whatever polarizer you will use, this polarizer will change the orientation of the this light. Suppose it's 45-degree, now it is suppose the 90-degree. Okay, after that, this the 90-degree polarized light, that will pass through the pocket cell, or this then what will happen, giving the voltage, you are applying the voltage here, right? So this the 90-degree oriented polarization light. So this 90-degree oriented polarization light, the orientation of the light will be changed. Okay, the polarization of the light will change, and due to the change in the reflecting index. So there is a variation. So when the light is coming from the this material, then there is a change variation in the polarization. So this light, so some orientation will change. 90-degree polarized light, the orientation will change. So again, we have to use this polarizer such a way that whatever orientation is there for this light, whatever light is coming from the polarizer, whatever orientation is there. So sometimes we will use the polarizer such a way that only the orientation, the suppose it is changed to suppose it is changed to 120 degree, okay, after the material, the polarization, there is a change in the polarization, that is changed to 120 degree. So if we use the 120 degree polarizer, then 120 degree light will pass through the um, pass through the polarization, we will get one intensity of light. Sometimes if we use the intensity such a way that the 120 degree light, that polarization light will not pass through the polarization, then we'll get a less intensity of light. So it depends on the in various way you can design. The main concept is like that. There is a interferometer through which also you can achieve the intensity monitor. But concept is like that. We are using the polarizer. Use the with respect to polarizer, you are using polarizer where whatever signal is coming from the pocket cell, and this signal can be through the pocket cell is the orientation of the signal is changed, and in addition to this, we are using the polarizer. So that whatever signal is coming from the pocket cell, whether it will pass through the polarizer or not, if it is passed, then how much orientation will be there. So according to those phenomena, we can change the intensity of light. Sometimes we will get the higher intensity light, sometimes we will get the less intensity light. And this everything, it depends on the polarizer as well as the pocket cell, where the orientation of the polarization of the light will change due to the application of the electric field. So this is about the intensity modulator. Okay. So the intensity modulator, this I told, this is one kind of phase modulator, intensity modulator. Till now, whatever we discussed, this is related to single channel waveguide optic modulator, because we are using the one material and one channel. We are only using so the one channel, one waveguide, we are sending the signal. In that, during the propagation of the signal, we are using the one material. Uh, but if you want to achieve the intensity modulator, you can also use the interferometer. For interferometer, we need a dual channel waveguide. Okay, we need a dual channel waveguide. So dual channel waveguide, two waveguide will be there through which the light will pass. Okay, so you can see there is a splitter through split. Two waveguide we are using through which red light will propagate, and at the other end, again the waveguide will be merged. Okay, so that's why the name is the dual channel waveguide. The light will be propagated through the two different waveguide for modulating the signal. Okay, so here also you can use the one material, here also you can use. So suppose the V amplitude light is propagating, it is split up into the two different part, plus V by 2 and the minus V by 2, and according to the phase it is split up, and if we use the two material here and here, if we apply the voltage, the phase of the this signal, two signal will change, and again it will sum into the this and due to the change in the phase, there will be a change in the output signal also. In this way, the you can get a modified output from the signal. So we are giving the electrical signal, the whatever optical signal, that is modified. So this is about the dual channel. Under the dual channel, there is a interferometer. So that interferometer, why the name is the interferometer, this also I will tell. So the Mach Zehnder electro-optic modulator, or Mach Zehnder interferometer modulator. So here also we are using the dual channel waveguide. So for interferometer, so whatever the concept we are using for getting the intensity modulator, this concept is based on the interference, constructive interference and the destructive interference. So we know that the constructive interference, so this is the one signal and this is another signal. If both signals are in phase, both are in phase, we will get the constructive signal, summation of the both signal. If both are in the different phase, suppose this is a one signal and this is a opposite, totally opposite signal, so what will happen, the destructive will get a very almost this kind of the signal, the minus, the subtraction between the two signal. You can say the constructive interference and the destructive interference. Due to the change in the phase, some signal will get that will be between the higher in constructive interference and the destructive interference. Some medium amplitude signal also will get based on the phase of the signal. Suppose here there is a one signal and another signal is like that. So there also will get some kind of the resultant signal at the other end of the optical waveguide. Okay, so first what it will do, the Mach Zehnder interferometer. So the signal, this is split up into two different parts. It's the one signal, this is the one signal getting. And if so the material you are using lithium liberant oxide, LiNbO3. This material is mainly preferred for all the modulator because it has the higher larger electro-optic coefficient. So if we are not apply, so here we have only use the LiNbO3 here only. In this section we are not going to use. So if we apply the voltage, then what will happen? If we now, if we will not apply any voltage, whatever signal you are getting, the same signal come into this one. Here you are getting the one signal, here you are getting one signal, both are in same phase, and we will get a constructive interference, right? You get a constructive interference. Now come to here. So in this case, this is the signal that is split up into two different parts. Here one part, and now we can see. So this will be the signal before coming into the material, or we were applying, if it's passing through the material, and if we're at the same time if we're applying the voltage into the material, the phase of the signal will change. You can see the phase of the signal will change. So resultant signal will get like this way. This one signal and this one signal, this one signal and this one signal, both will be cancel out. So destructive interference occur on the other side of the interferometer, so you will get a less intensity of the light, right? So in this way, the polarizer and the single waveguide we can use, but better we prefer the Mach Zehnder interferometer modulator. These are widely used in the photonic integrated circuit and optical communication applications for getting the. So this I told the two cases. The higher intensity is a totally constructive interference, and there is a destructive interference. Apart from that, if you control the signal such a way that it's not here, you can see the 180 degree phase shift. You can give the voltage such a way that there will be a phase shift in a different say suppose a 30-degree phase shift or 45 degrees phase shift like this. So for that, the phase modulator concept we discussed, right? And through the material only you can change the, due to the reflecting index only, the phase of the signal can be changed. How the phase shift is depends on the reflecting index. There is also a formula, this I've already discussed on the last class. So this is about the Mach Zehnder interferometer modulator. So next class I will discuss some other modulator. Please like, share and subscribe my channel. Thank you.